Good morning, guys. Good morning, guys. I hope you have a great morning. Thanks for tuning in to Citron's 29th webinar series. My name is Adrian, and I'm from Citron Technologies. So welcome again. Today we will talk about what is a relay. Okay, a relay is part of an electronic components. There are a lot of electronic components we can talk about, but today I selected this component called relay because I find it very useful to know about relay, to learn about relay, and how you can learn about relay using Arduino. All right. So again, if you are here for the first time, do drop a comment in the comment section if you have questions, and if you want to learn more about what is a relay, or any questions about today's webinar series, you can ask me directly, or you can join our Telegram group, which I will share by the end of the session. This session is a recorded session, and you can rewatch this session on our YouTube channel. And also, if you are watching this right now, you are also participating in our webinar series. You will be able to receive an e-certification after the session, at the end of the session, by filling a Google form. So without wasting more time, thank you guys for joining in, for tuning in, and I hope you'll find today's lessons or sharing informative. Actually, I didn't really introduce myself and on my background. My background is in electronics, and that's where I get involved heavily on electronics and also DIY stuff. And after thinking about what kind of sessions I want to do in all these Citron's webinar series, I thought of why not I share about the things that I learned during my university time, and stuff that you don't really learn in textbook, rather in the practical, where you tinker and you try it out, and then you explore different tools and components. So in today's session, I will talk about relay. Okay, this is a relay, and I will break it down in the simplest form. Don't worry, I won't go into too deep. I will make sure that this is student friendly. If you are a high school student or even primary school students, the session is suitable for you. And if you already know what is a relay, you will probably think of a high voltage, dangerous stuff. Better not show my kids. Um, I won't be showing any dangerous stuff here today. I'll try to make it safe, children safe, so that you can actually try it yourself at home. Um, so let's get down to it, shall we? Um, I think I have some questions already, but I will get back to you, Richard. I'll get back to you on your questions in a moment after we go through some of the content that was prepared for today. So the agenda for today is that I will talk about what is a relay. I will break it down, like literally I will break the relay down and let you see what's in here. And I'll explain to you what's in a relay, how it works, and why do we need it. And then later on, at the not the end of the session, but during the session, I will also do some demonstration on how you can use a relay to switch an LED on and off using an Arduino. And before I run the demo, I will explain to you why I'm gonna do that. And then at the second demo, I will be switching on and off a USB device. Okay, a USB device can be a charger, it can be an LED plug, or it can be any devices that has a USB plug. You can actually program it to turn on and off without destroying anything. So I will show you that as well, how you can connect a USB device, program it so that you can, program a timer or add a sensor so that it responds to the sensor. You can do a lot of things with a relay, right? That's what I'm trying to say here. So stay until demo 2 because demo 2 is going to open up all the possibilities that you thought may not be possible. Okay. So before I enter what is a relay, the reason why I choose relay is because a relay is a very useful component in the electronic world. You Once you learn how to use it, you kind of open up a new possibilities of projects. You can do a lot of things with relays. You are not tied down to the things that you know, such as Arduino, where you deal with small electricity, low current, low voltage kind of things. You actually open up a different category. You can do robotics, you can do automation on different devices, existing devices. You can actually control all these devices by using a relay. Right? A bit about what is a relay first. A relay is actually an electric switch, a switch which open and closes electronically. It doesn't look like a switch, it looks like a blue color tube thingy with some pins at the back. But inside is actually a switch. I'll open it up and show you later. So this switch, it's not like our normal conventional switch where you have two buttons over here where you flip on and off, on and off. Okay. This switch, yes, it's a switch, but you have to switch it on and off manually. But this relay allows you to do this on and off electronically. Means you can use your Arduino to program this to send a signal to turn it on or turn it off. So if you are using an Arduino, you can actually program it when to turn on and when to turn off without the need of using your finger to flip a switch. That makes it very useful. Okay. Another reason why relay was created is so that it allows small signals, small current signals to control a larger current or voltages circuit, a separate circuit. So you can use an Arduino to send, okay, this is the Arduino that I'm going to use later, Maker Uno, right? A Maker Uno to send a small signal to the relay to turn on a separate circuit that controls a larger current flow or that requires a higher voltage to operate. So it isolates these two different circuits, but it allows this small circuit, this controller to control a different circuit. So that's the whole reason why a relay is useful. An example is I can use my Arduino to program a signal to the relay to turn on my phone charger. Okay, I can't use my Arduino to charge my phone, but I can use my Arduino to turn on a relay to turn on my charger. And when I turn on my charger, it charges my phone. Right. So with the Arduino, if you have already learned the Arduino or if you have attended my past few sessions, you you have probably heard of the temperature sensor, right? Or different types of sensors. So you can actually add a temperature sensor here on your Arduino. When the temperature is too hot, it turns on the relay, and then the relay will turn on a different circuit, let's say, or turn off a different circuit. So you can perform an action based on what you program on the Arduino by controlling an existing devices out there. Okay, so that's the whole point of having a relay. So what's in this relay? Like I said, a relay is like a switch. Okay, there's a switch in the relay and it is activated with an electromagnet. What is an electromagnet? I highlighted here. And I'm going to break it down what is an electromagnet, and then I'm going to open this up and tell you and show you where is the electromagnet. But first, let's learn about electromagnet. Okay, this is a normal switch. There's no electromagnet in there. It's just a normal switch where you flip the switch and then it connects the circuit between these two pins. It just connects and disconnects. But with an electromagnet, you can connect and disconnect 2 points using a magnet to flip and connect 2 pieces of metal plate. Okay, I hope you're not confused. Here are a few diagrams to help you, understand or recall what you have learned back in your high school or primary school. This is a symbol of a switch. Okay, you have one pole at the center where it turns on and off. When it connects, it turns on. When it removes, it turns off. We call it open circuit or closed circuit. Connect, then it's closed. Remove, then it's open, means it's disconnected. So this is a normal switch. And this is a relay. Okay, if you can see something similar here, the relay also have the symbol of a switch above, but there is something like this twisting stuff at the bottom. Okay, that's called an inductor, or over here it's trying to show you that it's an electromagnet over there. An electromagnet controlling the switch at the top. Okay, so that is the electromagnet and above is the switch. So I'm going to build an electromagnet later and show you that how exactly an electromagnet can control a switch. Electromagnet in the relay, a switch doesn't have electromagnet. So how can an electromagnet in this relay control the switch in there? Okay, so now I'm going to talk about a bit about electromagnet, and I'm going to show you, I'm going to build an electromagnet on the spot. Okay, I'm going to pause here for a moment and answer Richard's question before I go into deep. Okay, touch some info difference between Maker Uno Plus and Maker Uno Nano. Okay, all right, it's okay, since it's not so much on the topic on relay, I'm gonna give you a very quick answer. The Maker Nano Uno Plus and the Nano, the biggest difference is the size. One is big and one is small. From my experience, Uno and Nano, basically they have both similar features, except for the sizes. And some of the pins are like the power pins, the power input, how you want to input the power, how you want to power on the board. So when it comes to size, right, it really depends on what application you want to work on. And Other than that, I think they share the same microcontroller, the chip. So you have to make sure, you have to check and see. The microcontroller, I think, is 328P, and they both share the same I/O pins. So the only difference is the size lah, from what I know. Okay, so do check it out. I hope I answer you in a very brief manner, and you can go to visit the website and check on the datasheet as well. Okay, continue on the topic. What is an electromagnet? Electromagnet is a type of magnet in which the magnetic field is produced by electric current. It means that you don't really have a magnet, you have nothing. You have a string of copper wire, and then you have some batteries, and then you want to create magnet. You have a nail, and then you want to create a magnet. Okay, so basically you are trying to create a magnet out by producing electric current through a coil, a copper coil. And this results in a magnet. Okay? I'm gonna switch my screen so that you have a better understanding. I think some people understand this concept of electromagnet, and maybe students who don't understand it quite much, but I'm going to show you anyway. And this is a good experience for you and the kids or your students to try it out at home. Okay, just a quick one. I'm going to share my camera here. Okay, I have a copper wire. You don't really need to buy a copper wire. You can pull out the copper out from a normal wire, a single core wire. And then I have a nail, a screw, and then some paper clip and a battery. Okay, I have 4 battery here. All right, it's about 5 to 6 volts, and then I already connected to this thumbnail here. Okay, this is for me to connect my wires easily later. So first things first, I will need to coil my coil like that. Just go circular way. I hope I'm not blocking you, and then push it down. Okay, I don't have a lot of freedom angle. I hope I'm not blocking you. Okay, turn the coil over and over again, push it down side by side, and then twist it, twist it, twist it, twist it, push it down. You can actually directly twist the copper wire on your screw as well. So right now I'm trying to create an electromagnet to demonstrate how current creates magnet. And essentially I try to explain what's inside a relay. So before I show you what's in a relay, you have to understand this concept first. So I have my coil, and then I'm gonna take it out, and then I'm gonna put my screw in. Okay, like I said, you can actually twist your coil on your screw, and that's fine. Okay, it works as well. So I'm just gonna screw my coil in my screw like that. See this 2-point? Okay, this makes a fun activity for kids, for young kids. And I'm gonna bring my battery here, connect it here and here. Now I have my magnet. Okay, how do I know if this is a magnet? This is where the paper clip comes in. Just take the pointy edge of my screw, and then twist it down a little. Okay, once it's hot, it means that it's connected. Okay, it's warming up. Okay, you're trying to create an electromagnetic field like a magnet. Okay, connected. Hold on. Actually, I have a backup. so that I don't have to find out. Okay. Unless I drain all my battery already. You can see. Okay, it's actually a magnet right now. Yeah, I drain all my battery off. Right, this process actually takes a lot of, it's just connecting an inductor and it's draining a lot of battery. Try to at least lift the pin. But again, give it a try. I'm gonna do another backup, which is 2 coin cell battery. Put it side by side like that, and then just press it together, and then I got my magnet. Yeah, I suspect it's the battery. It's running out. So this is a magnet, and by just coiling some coil around a screw, you can create a magnet. So this is a magnet, an electromagnet. If you don't apply the battery here, it doesn't really, okay, there's still charges here. So you see, it becomes sort of like a temporary magnet. There's still magnet here. Okay, I didn't charge this screw before this, but right now there's magnet in here. So this is an electromagnet, and this is a relay. I'm just gonna go ahead and tell you what's in a relay. A relay is basically a piece of electromagnet like this, but in this form. Okay, this is me opening up the relay to expose the coil. So by turning the coil round and round around the screw, you create an electromagnet. Over here, there's a coil, you see, copper, going round and round in circles on a piece of there's a shaft in the center, and then if you apply a small current like the battery at these 2 pins, then it will actually turn this switch down. It's very tiny and blur. I'm not sure if you can see, but actually there's a gap between the top and the bottom of this. So when I press this, it's actually clicking. There's a clicking sound here. Yes, that's what inside. That's what in here. You can actually break it off, right? It's basically a coil, an electromagnet here. When you apply current into this electromagnet, it becomes a magnet, and then when it becomes a magnet, it attracts the top piece here to connect on the circuit. So it's like a switch. When you apply current, the electromagnet activates, become a magnet, and then the metal will stick on the magnet. And when you disconnect the power, the electromagnet, it will stop becoming a magnet, and then it will release the latch from the top. So it turns on and off the switch by activating and deactivating the electromagnet here, by applying current and not applying current. Okay. Actually, this guy is very cheap, like maybe 1 ringgit or lesser. I got a lot, and if you get this kind, you have to solder it yourself. So I've decided to open up one and show you guys. Okay, it's a very interesting thing, and actually you can connect some power supply and then see this thing move. So I'm gonna do that later. We're using my Maker Uno. So another relay that I would like to use is this relay. This is a very common single channel relay. It basically connects every pin down here into this ports and pins and LEDs for you. So you don't have to solder anything. You can just directly take your wire and connect it, screw it in, and then connect your wires, power on the relay, and then you can use it almost immediately. It makes it simple, and students can try using this kind instead of this. Even though this is so much cheaper, but to use it, you need to solder it on PCB and stuff, and it makes it troublesome. Okay, so this is what I'm going to use in a demo lab later. Let me go back to my slides to show you some symbols again to demonstrate the difference, and also I'm going to continue on what is a relay. Let's see some questions. That's what inside the relay. Yeah, that's what in the relay. If you have relay, then you can try to open it up. But this is the standard relay. There are many types of relays out there. Okay, this is the single pole. So the single pole kind of relay means it looks simple and straightforward. You turn on the electromagnet, you connect the circuit. Do you have any giveaway some relays? No, unfortunately, I'm not giving up any relays, but I will show you the website to get relays. The relay that I showed you just now, this kind is actually just 4 ringgit, and it's quite durable. It can flip like a few thousands of flips, and you can get it easily, and you can try it out. You can get it on a local component shop as well. Okay, why relays have many channels? It depends on the application. So this relay that we are talking about is a single channel kind of relay where you control a single circuit. But some applications, they have many things they have to control. They need to control 1 light, 2 light, 3 light, 4 light, or 1 fan, 2 fan, 3 fan. Multiple devices they have to control. So instead of using all these single channel relays, they come with a one big board with all the relays built in on a single board. There are 5 relays in a single board, or there are multiple relays in a single board. Okay. Just a quick show, right? This is Citron's website, and if you search relay, there are so many types of relays out there. For students or beginners, I would just recommend you get the single channel 5-volt relay breakout board. Breakout board means that everything down here is already connected. It's simple. You just need to plug everything in. Scroll down and you will learn that to run this relay, you need 5-volt ground and a control signal from your Arduino, and it's active low. It means that when there's no voltage entering the relay, it turns on, it connects the circuit. And when you apply voltage, it turns off the circuit. Can't really imagine, right? Later during the demo, I will show you again. Okay, but this is the recommended relays for students to try. And then there are, of course, many other types of relay. 4-channel, 2-channel, 8-channel. The price differ according to the channel. Having multiple channel means that you only need to supply 1 wire, 1 pin to the entire module. Then all the relays are powered on, and you can supply signal pins. Let's say 8-channel, you have 8 pins to power on each of the relay. If you have 8 individual single channel relay, you have to connect 8 times power supply to every single relay. So it's very troublesome. But that's the whole point, right? It depends on what application you want to do. Okay. One last question. Can we use 12-volt relay to Arduino or only 5-volt? You can't really activate a 12-volt relay on your Arduino because your Arduino can't provide 12-volt to your relay. So it's recommended to use a 5-volt relay on your Arduino. If you want to use a 12-volt relay on an Arduino to an Arduino, then you will need to have an external 12-volt to power up your relay. And then you have to figure out how you want to use the 12-volt. How do you want to control the 12-volt relay from your Arduino? Do you need to step up the 5-volt to 12-volt, or Will it be able to accept 12 volt? So you need to think about a lot of things when it comes to 12 volt. The Arduino, most of it is built for 5 volt only, and you really need to consider all these steps. Are like, do you want to use an external power just to power up a relay? So something to consider. But again, the answer is yes, you can. You can, right? Anything is possible, but is it worth the effort? You have to think about it now. So this is what I showed you earlier. To create an electromagnet, you coil some wire around the iron nail or screw, and then you apply battery or current through the wire or through the copper wire, and then it will instantly become a magnet. So this is a makeshift magnet, and in the relay, which is what I showed you earlier, this relay, it's very difficult to see because through the camera, but this is what is inside. This is a very I like this drawing because it shows very clearly on what it looks like in there. So over here, number two is the electromagnet with a coil in there, and number one is to the circuit, let's say from your Arduino, supplying a current to your electromagnet. When number two becomes a magnet, it will attract this armature or the movable armature up and down. It will attract it downwards, making this contact to touch number three. So when it becomes a magnet, flip, it touch, then this circuit will become a closed circuit. It will become a complete circuit. And then the current will flow to number four. And number four is LED. So again, on this schematic on the right, when you apply a current to your electromagnet, number two, it will attract the switch, flip the switch, and make a complete circuit to turn on your LED or your fan or whatever devices on the other end. Okay. So in my demo one, I'll be switching on and off an LED using a relay, just an LED, a very simple project. I know you can turn on and off an LED using your Maker Uno, but I just want to demonstrate to you. You can do it on a Maker Uno, on a relay too. It's an extra step. You don't do it in a real application. It's just to demonstrate to you how a relay works. And then you replace the LED with something else, which is part 2 demo. Okay, let's see. One question from Richard. How to set up multitask loop coding to multiple relay output? Simultaneously turn on 240 volt light and 240 volt fan tank. Okay. Simultaneously. If you talk about simultaneously, then you have to talk about what kind of microcontroller you're using. Certain microcontroller only supports in sequence. It can run in sequence, but you can use different watchdog delays, or you can use different methods to try to achieve synchronous for relays synchronous. Yeah, how you want to supply two signals at the same time, but there's always certain delay between two signals. Okay, if the speed is very essential, it's very important, then you have to look at the motherboard instead of the relay. How do you want to program that controller to send two signals simultaneously? Okay, it's a whole different topic. Simultaneously, sending signals on the same period of time. It depends on the core of your controller. All right. But again, it depends how critical it is. Do you really need to make sure that both turn on instantly? Will that millisecond in between this turning on affect the output? You have to think about all this. If it really does, then you will need to look at the motherboard, what kind of motherboard you have. Okay. I don't really have a straight answer for this, but it's it's possible right? Depending on the controller. Okay, no more questions, right? Let's move on to the demo here. Okay, the demo involved with a Maker Uno, an LED that is already connected to a resistor. Don't ask me how to do this. I've shown you this in a previous session. So an LED, right? You have your anode and cathode. So you just need to know where it is. Some jumper wires, okay, and then a relay and a screwdriver. Okay, these are the things that you need to turn on and off an LED using a relay. So first things first, you will need to connect your relay. You are not going to connect the Maker Uno to the digital pin to your LED because you're not going to power on the LED using any digital pins here, even though you can. Now you want to isolate these two. These are two different circuits. Okay, Maker Uno, LED, LED. So now I'm going to first power up my relay. The relay here, there will be labeled in ground and VCC. So in is the signal to turn on and off this relay. Ground, you have to connect to ground, and then VCC, you have to connect to 5 volt. This is a 5 volt relay, single channel relay. So I will need 3 female to male jumper wire. I will directly connect it. I'm sure you guys know how to connect, right? Okay, like that. 3 female jumper wire, and then the VCC connect to 5 volt on your Maker Uno. The ground connect to ground on your Maker Uno, like that. And the the signal, connect to any digital pin on your Maker Uno. So I'm going to connect to pin number 7, like that. I'm not going, okay, later I will show you the code that I've already programmed in my Maker Uno, but I'm just going to tell you what's in here. It's basically to turn on and off pin number 7 for 5 seconds on, 5 seconds off. Okay, it's a very simple code. Digital write high 5-second delay and digital write low 5-second delay. Right, as simple as that, just to demonstrate to you how it turns on and off a relay. Next, I will need to connect this side of the relay using a screwdriver. So these are the terminals, screw terminals. You have to remove the screws. If you bought your relay from China, there will be Chinese word over here. Okay. So from left to right, left means I'm gonna read it out in Chinese. It's called 常开. 常开 means it's always open. And then at the center, it's 公公端. But on the right side, it's always closed. 常闭 means it's always closed, and then on the left side, it's always open. If you look at the data sheet, it's not in Chinese, it's in English, and then normally it will wrote OC, and then there's always open, and then there's always close, right? There's open, and then there's close. So the always close means that when you, by default, if you don't apply any electricity, it's connected, and then if you apply electricity, then it's the opposite of the always open. In this case, I'm going to connect the LED wire. I'm going to separate a circuit over here so that it runs and turns on and off when it needs to. Okay, so what I'm going to do now, a red wire connected to the center pin. I think it's easier if I demonstrate it, then you will be able to understand rather than I talk. Okay, and then part 2, I am going to connect this to 5 volt, this to 3 volt. Let's say I'm going to use 3 volt. So 3 volt is going to enter here. And then now I'm going to connect another wire to this side. And screw it down. So 5 volt enter here. When it switch on, it's going to go into this orange wire, and then it's going to enter this LED. Okay. So now this is a switch in between here. It either connect these two wires together or disconnect them. And then at the end of this connection, there will be a ground. My ground will have to go back to my Maker Uno. Connect it to ground to complete the circuit. So do you see it? 5 volt entering here. If the switch is off, it won't continue to go back to the LED. But if the switch is on, it will complete the circuit, send the current into the LED, turn on the LED, and go back to ground. A complete or closed circuit. Okay, so this is a complete setup. I just need to power it on, power your Maker Uno on, and see the relay works. So get a micro USB, send some power in. All right, turn on the power. The relay is gonna turn on, and then red color means that it's off. Okay, so pin 7, I already programmed it. When it turns on, then it will activate the relay. Okay, let's see if I connected my LED polarity correctly. Let's double check. Okay, 3 volt entering, close, ground. Oops. Okay, so bear in mind that everything here is electronic, so don't worry about getting shock. Double check all the connection. VCC 5 volt, 3.3 volt. Swap the polarity. That is the correct relay. Okay. While I look at the circuit, I will also look at some questions here. Yes, so by right, the current should flow into the LED from the 3.3 volt. Okay, let me just quickly flip the LED. The polarity is right. Change the breadboard. Connection. Okay, for safety, I will just turn off the power. Volt. Right, sometimes it could be the wiring. Right. The worst case will be the wiring, right? It won't be anything else. The wire internally disconnected. Five seconds. Still not turning on. I'm gonna switch a different relay right now. All right, while I troubleshoot this, guys, if you have a question, feel free to ask while I work on it. Yes, this is a normal opens, and I connected it normal open at the beginning. So let's try a different relay. My power should be correct. VCC, ground, and input. Okay, I'm switching a different relay right now. Green to ground, blue to in, correct. 3 volt. Okay, normally open, and O. Okay, this is normally closed. Turn on the power. So every time it turns on, there will be a flip, a sound. LED positive, negative terbalik. Let's double check I think really terbalik nih. Okay. 3.3 volt. It's really unlucky if one of the wire internally patah. Okay. I'll quickly switch a different LED. Ground. Different ground. Okay, let me get back on this in a moment. All right, it was tested yesterday and it works fine. But yeah, the connection is like that, and there's something wrong somewhere. Okay, guys, so back to the slides. And if I have remaining time, then I will continue on with the questions. But part 2 demo is a more, actually it has to, the demo 1 have to work before I move on to demo 2. But again, I'll be moving on to demo 2, and demo 2 involved with using an LED USB light bulb. Okay, this light bulb is USB powered like this, USB powered, and I like to use this USB connectors. So these USB connectors, you can actually buy it separately, and then you just need to connect the wire yourself, solder the wire yourself like that, positive and negative. And with this, you can actually tap into your whatever USB devices, and then control when to supply power to your USB devices by using a relay. Okay, the reason why we use a delayed relay is because we know that the Arduino won't be able to supply enough current to your this kind of light or even your phone charger. So you need to use a separate external power, and the external power comes from the plug that I'm using right now. Okay, a normal plug. All right. So before I move on to that again, I'm gonna give the relay another try. Hopefully it works. From Richard's suggestion, 5 volt. I'm gonna give that a try, 5 volt. 5 volt. So I will need a separate wire for 5 volt. Okay, now everyone shares the 5 volt for the LED. Yeah, not my lucky day. Okay. Seems like the relay is not behaving. I'm gonna put everything back into place and go ahead and try with demo 2. Ground. Okay. Ground. It's quite blur, right? The camera. Why is the camera blur? Yeah, you can hear the clicking sound, right? And then the LED shouldn't light up this way. Okay, unfortunately, because of this, I highly doubt that if I try using the LED over here, it will work as well. So should I give it a go? Given the time, maybe I should leave it to part 2 instead. Try changing a resistor. Right now I'm using a 220 ohm resistor. My ground. Okay, let's say I bypass my resistor. Go straight to 3.3 volt. And then all right, I'm going to wrap this up. Trying to solve this issue right now within the time given is not very, viable. But how I'm gonna wrap this up is that I am going to share with you on the schematics, the solution, and also the whole setup, including the demo 2 setup. I will take a photo and I'll share it with you in a Telegram group later on today. And then I will tell you what's the problem that I'm facing. Maybe I don't see it right now during this webinar series. And I'm very sorry you won't be able to see the results, but I want you to learn from today's session. I've really find this, um, using a relay is useful when you know how to get it work. You can turn on pump, you can turn on fan, you can turn on many things. I'm not referring to AC stuff right now, unless you're very confident with using AC, um, dealing with AC, but you can use a relay for DC application. And yeah, once I get this to work, I will share with you on the schematics, photos, and even today's slides. If you're interested, you can PM me as well. I will share it on the Telegram group, which is over here. So if you want to learn more on things like what I'm sharing in today's series or in our next series, I'll be updating what we have in our next series in this Telegram group. I'll always share about what we will be talking about in the next session. Today's session wasn't that great, but I will make it up to you by sharing the schematics, the things that we are trying to work here. Join us in our Telegram group, scan the QR code, or here's the link, and then I will see you in there. You can ask me questions as well. Given the time, I will be able to answer you more effectively. And then, and again, I appreciate you guys for trying to help troubleshoot the issue that I'm facing right now. Okay, thanks for the understanding. And I really hope that you find today's webinar informative, even though the results wasn't what we expected. Again, thank you for joining. So over here, if you have thoughts or feedback that you would like to share for today's session, scan this QR code, or here's the link. I'll put it in the comment section. Then let us know what you think or what you want to hear next. Bear in mind that all these sessions are made for students, children, especially high school students who are learning RBT or coding in part of their syllabus. So if you have friends with children who are going through this syllabus and they are learning it from home, you can ask them to join in this session. I try to make it as simple as possible so they can experience all this and learn it by themselves. But again, drop me a feedback and do insert the correct email in this feedback form. You'll be able to receive an e-certificate after you submit the form. Here's the link. And yeah, thank you again for attending to this session. I will see you on the Telegram group. Thank you very much, guys. Okay, I have a few more minutes, so I'm gonna look at the relay right now.